So yesterday we discussed the way to determine that two functions are inverses of one another is if you can represent f of g of x and g of f of x as x itself. So if you can construct these two compositions and they both give you the function x, then they must be inverses of each other. So that's what we need to do to check to see if these functions are inverses. So I'm going to calculate here f of g of x, which means I need to plug the g function into the f function. All right. So by plugging in the g function into the f function, I end up with 4 times the g function plus 3. I'm going to distribute that 4. It's going to cancel in the first term. It's going to cancel in the second term. And x minus 3 plus 3 is x. So it's looking pretty good. I'm also going to need to do the same thing, though, when calculating g of f of x. So let's go ahead and do that as well, hoping that works out the same way. So that's going to be g of 4x plus 3. Since these two terms have the same denominator, I'll go ahead and combine them. And I can simplify the numerator, and those 4's cancel. So because I ended up with x in each of these, that means f of x and g of x are inverses. All right. Let's go ahead and check to see if the same is true of h and j. So I'm going to need to check h of j of x. And I'm also going to need to check j of h of x. So let's go ahead and set each of those up. So I'm going to be plugging each of those equations into the other. And let's see what that's going to look like. So in my h of j of x function, it's going to work out sort of nice in that I can cancel the square root and the exponent there. So I'll have x minus 2, but that gives me x minus 4, which is not x. So that automatically right there means that h and j are not inverses. And I could check the same thing with j of h of x, but I'm going to end up with the square root of x squared minus 4, and I can't go any further than that anyway, so I'm sort of stuck there. Okay. The second part of this lesson is figuring out what the inverse of a function looks like if you're given that original function. And so in order to figure out what those equations are going to be, we need to remember that the inverses flip your domain and your range. So all xy points become yx points, essentially. So if this function gives me y coordinates using x coordinates, then my inverse function is going to give me those x coordinates if I plug in those y coordinates. And this is where we start in determining the equation of the inverse function. We say all of our inputs need to be outputs and all of our outputs need to be inputs. So let's flip our x's and our y's. But remember, when we write the equation of a function, we needed to say y equals because we want to know what our outputs would be given the inputs of x values. So this is where I need to do some rearranging to figure out what my y would be all by itself. And now y is alone. So what I've figured out then is that my inverse function would be x minus 3 over 2. And I could test that by plugging my inverse function into my original if I want to check to see if I did it right. So that would be 2 times x minus 3 over 2 plus 3. But really these cancel. So I have x minus 3 plus 3, which is x. So it seems like I did do it right, and I could flip it and go from the other direction as well, and I would find that it's correct. All right, so let's do the same thing with g of x down here. Remember that right now it's giving me y values as my output. So if I want the inverse of this function, then I want my inputs to be my output, and I want my outputs to be my input. And now I have to solve for x, or solve for y. I need to get y alone. So I'll multiply by 2 on both sides. That's the 5th root of y minus 1. So I'll need to raise both sides to the 5th power. Remember to raise this whole side to the 5th power. And I'll have 2x to the 5th equals y minus 1. And then I just have to add 1 to both sides. So I'll have 2x to the 5th plus 1 equals y. Probably would be better if I were to actually raise the 2x to the 5th, or simplify that 2x to the 5th. So 2 to the 5th is 32. So I can rewrite this as 32x to the 5th plus 1. And so that's the equation of my inverse function. All right, let's do a couple practice problems. So remember, for each of these, we're just trying to figure out if these functions are inverses. So for the first one, I'll need to know if f of g of x is actually x, and I'll also need to know if g of f of x is actually x, and same for h and j. So I would pause the video now, and I'll put the answers up here in a second. So for f and g, you do get x for each. Therefore, f and g are inverses. But for h of j of x, I already get x plus 3. So I don't even have to check j of h of x. Even if it comes out to be x, it's not going to matter. And that is possible, but that won't matter. So I already know that h and j are not inverses. All right, and the last two. So in this section, you're asked to give the equation of the inverse of each function. Remember that you have to first consider that your outputs of any function with an input of x are y values. So if you consider that these functions would give you y values as outputs, then their inverses would give you x values as outputs. Or those inputs that were x values in f of x are now outputs in f inverse of x. And now I would pause the video, and you'll see f inverse of x and g inverse of x in a second. So these are the equations for f inverse and g inverse of x. Could you FOIL out x minus 1 cubed? You could. I don't expect you to, though. So this would probably be the best way to write g inverse of x.